Alrighty. So let's trace the history of how this is developed, right? There's different kinds of rates of change. There is the average rate of change. Okay, anytime the word average is thrown in front of that, then you know you're using f of b minus f of a over b minus a on a closed interval. And the closed interval goes from a to b. That average rate of change is also the equation that we use to find the slope of a line. The slope of lines are also done with f of b minus f of a over b minus a between 2 points, which is the closed interval. And, but in algebra we teach it as y2 minus y1 over x2 minus x1, but it's the same thing. The slope of lines between 2 points. The entire premise of calculus being a necessary math, geometry and algebra have existed as mathematical studies, way before Christ. They were studying geometry and algebra. But calculus is like a baby kind of math topic because it didn't come into birth until the Renaissance, right? Until Sir Isaac Newton. So the pivotal point is that they had to go from figuring out the slope of a line to figuring out the slope of what? A curve. Okay, that's what made calculus necessary, is that we needed a way to be able to figure out the slope of a curve. And we would do it at 1 point instead of 2. So Leibniz, who invented it first, what was Leibniz's downfall though? He came up with the idea first, but what didn't he do? He didn't publish. Okay, so he didn't get credit. But Leibniz came up with it first. And what Leibniz did was take that slope of a line formula, and all he did was throw a limit in front of it. All right, well, if I can find the slope of a line, then I should be able to find the slope of a curve by taking the limit as those 2 points become 1. And so what goes under the limit as the approaching? A approaches B or B approaches A, either one. Okay, A approaches B. As those 2 points become 1, if you take the limit, that was Leibniz's definition. He just failed to publish, and so he didn't get famous. Oops. No, I was right the first time. Okay, Johann Leibniz, German mathematician, rival of Sir Isaac Newton. He developed that first. Newton had the same thing, only he wrote it as a plus h minus f of a all over a plus h minus a. So instead of b, he's using a plus h. His thinking is that a and a plus h are super, super close to each other as long as h is really small. How small should h be? And that can't be 0, but it could be approaching 0. So h approaches 0. And we know that the denominator can simplify. We're not going to leave it as a plus h minus a. We're just going to say it's just going to be all over h. And that's Newton's. Oops. Weird. All right, here's Newton. And he got his published, and he went down in history as the inventor of calculus. Sneaky little devil. What? He had a pretty big ego. Remember? I mean, the story is, like we talked about last year, so they had a whole, like, judge and jury thing to, like, decide what it was, but he was the judge. Like, he presided over the thing himself. Huh? My suspicion is yes. Is that, I mean, they were cutthroat. They were pretty much all about their own fame and glory. So.
How do you work that out so that the other side is like okay with it?
Well, there was no other side. That was the point. Is that this was, this was a scientific debate. It's not a trial. I mean, it was not like they went in front of a court or something, but it was a scientific debate held by the London Scientific Society, and so everybody's presenting their sides, and the person who made the decision was Newton. Because he was the president of the society at the time. There you go. All right, here we go. So how do we use these? So yes, for this lesson, I'm going to need you to show me the slopes of the development of the slope of a curve. Okay. Find a tangent line and a perpendicular line, normal. Okay, the word normal is not the opposite of crazy. Okay, it is perpendicular. So find both a tangent line and a normal line through the coordinates, through x equals 3. Along the curve f of x equals x squared plus 2x. So just visualizing, what's going on here. All right, x squared plus 2x is a parabola. The parabola goes through. Struggling with these different colors here. Okay, the parabola goes through the origin and then back up through the number 2. So here's our parabola. We are concerned about the point 3. So that's going to be up here. And then we want to come up with the tangent line. So just by looking at it, what type of slope will the tangent line have? Will it be positive or negative? Positive. All right, so the tangent line is going to come up, skim through that point, and then head off. So we'll come up with what that line is. And then the normal line is going to be perpendicular to that, so it will have a negative slope coming through here. So those should make perfect right angles going through the same coordinate point. So we're just coming up with those two lines. So we know the point, this point right here is the point 3 comma, and what's the y value of the point right there? And my graph is not to scale. 15. Okay, that's 315. That's just by plugging 3 squared plus 2 times 3. So it's 315. And then we want to find the value of the slope along that curve. Yeah. Let me see. Yeah, no, you're not going to change the drawing. I just changed the equation and made it a minus instead of a plus.
Oh, okay.
But it's not letting me fix this, so 3, 3. Okay. You want to use Newton or you want to use Leibniz? Doesn't matter to me. And do Leibniz? Okay. All right. The limit as A approaches B of f of b, so that's b squared minus 2b minus f of a, which would be a squared plus 2a, all over b minus a. All right, so f of b minus f of a. This has to do with factoring. So you want to group the terms according to their power. And so we want b squared and a squared grouped together. And then we want 2b and 2a grouped together, so we're grouping according to power. And then we factor. Oops. All right, so how do you factor b squared minus a squared? Okay, b minus a, b plus a. Okay. And then I'm going to factor out a minus 2. And that will leave me with b minus a. And the whole thing is also over b minus a. And so by factoring, I can see that the squared term had a b minus a factor. The term with the coefficient of 2 had a b minus a factor. And the denominator has a b minus a factor. So those b minus a's can reduce all the way through as a common factor. So I'm left with b plus a minus 2. And a is approaching the value of b, so that'll be 2b minus 2, which we already knew that was going to be the derivative anyway, but now we came up with it. Yeah? Then you'll end up with 2a minus 2. Either way, we're going to plug the number 3 into that. So at x equals 3, the slope is 2 times 3 minus 2, so the slope is 4. Which we expected. We expected this to have a steep positive slope. So my tangent line in y minus y1 form would be y minus 3 equals the tangent slope of 4, x minus 3. That's the equation of my tangent line. My normal line will be perpendicular to that, but through the same point. So that will be y minus 3 equals, and then when we have a perpendicular line, the relationship of the slope are the opposite reciprocals of each other. So I'll be looking at negative 1/4 for the normal line. And so now you've got the equations of the two lines that will make a perpendicular relationship to each other through the point 3, 3 along the curve. You don't have to simplify those. You could leave them like that. Okay? All right, any questions on that one? Okay, and then the last one I just want to review with you is just if you were to find the average rate of change along the curve g of x equals x cubed minus 4x, and that has to be on a closed interval, and so we'll say the closed interval is from 1 to 3. That doesn't take any limits because it's the average rate of change, and the interval is closed and we're not at one point, we're at a full interval which has a beginning and an end, a first point and a last point. So don't get sucked in to thinking that you got to do limit, just watch carefully for what they're asking for that average rate of change. And so the average ROC for this one would be whatever g of 3 is minus g of 1 over 3 minus 1. So g of 3 is going to be 27 minus 12. G of 1 would be minus 1 plus 4. And then 3 minus 1 is 2, so we would simplify. 27 minus 12 is 15, minus 1 is 14, plus 4 is 18 over 2, so the average rate of change is 9 along that interval. The only other thing I would wonder is, do you want me to show you a Newton for practice? Just keep that, yeah? Okay. All right, so we'll do 1 Newton then. All right, find the slope of the curve. Okay, find the slope of the curve along, we'll say, P of x. And we'll have that be, say, 2x to the 4th minus 5x squared. And we'll apply the Newton strategy to doing that. And we'll do it at x equals 1. So Newton's strategy said to use, oh, that's mean of me. Let's not do a 4. Why is my erasing? There we go. Let's just do keep it at least a little simpler. We'll do a cube. All right, so Newton's says to take x plus h as a quantity and plug it in, and then just do regular f of x and divide the whole thing by h. So what would that look like? So f of x plus h means 2 has to have an x plus h in it and cube it, and so does the 5. Okay, so there you go. You've got your x plus h, you're cubing it, your x plus h, and you're squaring it. And then you subtract just plain old f of x. So I'd subtract 2x to the 3rd plus 5x to the 2nd. And I'm going to divide all of that in the end. I'll reduce it all by h. And the algebra is at first messy, and then all of a sudden it will be gloriously simple. So you're going to have to FOIL a little bit before everything will reduce away. When you FOIL a cubic, you'll have x cubed plus 3x squared h plus 3hx squared plus h cubed. So that is a cubic FOILed out, x plus h times x plus h times x plus h, minus, I'll have 5 times the binomial squared, so x squared plus 2xh plus h squared. Again, I told you it's ugly at first, and then it's all going to simplify. And then we still have minus 2 cubed plus 5x squared on the end. And that whole thing is all over the expression h. When we distribute the 2 and the 5, 2x cubed, 6x squared h, 6hx squared, 2h cubed. So I just distributed the 2. When I distribute the 5, minus 5x squared minus 10xh minus 5h squared. And then at the end I still had my minus 2x cubed plus 5x squared. That was the original subtraction. All of that is over h, and this is where things start to get fun. What happens with the last two terms? The negative 2x cubed and the positive 5x squared. They cancel out because their opposites are in front of them. And so the 5x squared has a negative 5x squared right there, so those are gone. All right, the 2x cubed has one out here. And then what is common between every single term that's left? What do they all have at least one of? They all have an h. And the whole thing is over h. And so I can reduce all of them by a single h. And so what I'm left with is 6x squared without an h, 6sh, 2h squared, minus 10x, minus 5h. And now h is approaching 0. And so all the terms that still have an h in them will all have 0 plugged in. So that'll be gone, that'll be gone, that'll be gone when I plugged in my h value. And so what I'm left with is 6x squared minus 10x. And at the number x equals 1, the slope will be, plug -1 into that equation, -4. So it's Newton's method. The difference between the two methods, Newton's method is algebra heavy. It's like FOIL it all out, and then cancel, 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 reduce, 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 done. Leibniz's method is factor it all, grouping by like powers. When you group your powers together, then they will factor, and then it will reduce. And both ways you end up with the same thing. Just different approaches.